Welcome everyone to tonight's 2022 Open Eco Homes tour with Ralph, a retired architect. We're really pleased to have him sharing his 17th century Suffolk timber framed house project with us tonight. My name is Nicole and I'll be chairing. We also have Nicola, who's going to be doing supporting us with the Q&As tonight. And there are a few housekeeping things I just want to check before we start. So do stay muted unless you're called upon to ask questions. Feel free to write questions, comments, or suggestions in the chat. We will be recording this, so while we welcome seeing you, if you'd rather not appear on screen, feel free to click your Zoom camera off. After tonight's tour, there will be slides, case study, chat, and video of the tour emailed to everyone who's booked in a day or two, so you'll have a chance to look at it again. And the structure of the session will be in two halves. So Ralph will present the first half, then we'll have Q&As, and then the second half and Q&As. So I think we're ready to start. So over to you, Ralph.
Thank you, Nicole. I think what I'll do is I'll just start by explaining why this happened the way it did, so that people understand where I'm coming from, and maybe I can give them the confidence to do the same thing themselves. My background is as an architect, and at the time that this project was launched about 2 years ago, I was actually an RIBA councillor for the East of England, and I was on the RIBA Sustainable Futures Working Group, which then delegated me to take part in the LETI, London Energy Transformation Initiative Climate Emergency Retrofit Guide document, which took a good year to produce and which will feature on one of the slides in a moment. So you'll be able to make a note of that and access it if you want to get more information. My house is 17th century, as Nicole said, built in around 1600, and the actual original building is the section which you can see with the clay pantiles on the roof. We bought it in 1984 and extended it, so the section which has now got the zinc roof was added in 84. Of course, at that time, materials were pretty basic. Insulation was minimal. There was not really any discussion about natural materials, breathable materials, or even airtightness at that point. So we decided 2 years ago that we had to completely redo the house after 35 years. And this takes us through the journey that we went on to achieve that. So let's go on to the next slide. Okay, so this is a case study showing a retrofit of a typical 17th century timber framed house. And when I say typical, in Suffolk, we tend to have a lot of houses which are modest in stature and are 1.5 stories high. So the upper floor goes into the roof space and you don't tend to have a loft. It's essentially 13 meters long and 4.5 meters wide on 2 floors with the kitchen extension. So the total footprint of the original building is about 170 square meters, although that's not all usable space. As I say here, the anticipated completion date for the project is about December this year. It's slowed right down because people have disappeared off site and it's difficult to get them back, but that's the plan. So moving on. Okay, so this is an aerial view of the house before we started work. I just happened to take this from a scaffolding on another bit of the building. And you can see the original part of the building on the left, and then what we call the kitchen on the right, both pan-tiled at the time, and with some solar thermal on the roof and various bits and pieces. Okay, next. The climate emergency that I referred to had this as its introductory text, and I won't read it, but essentially they are saying that everybody needs to do a deep retrofit of their buildings if we're going to get anywhere near the 1.5 degrees that we've pledged to achieve. And Letty's climate emergency retrofit guide is a really good tool to help people understand the complexity of it and give them guidance as to what they need to do first and how the process can work. But I'll let you read that introduction in a moment and we'll move on. So this is just a little bit of context. I challenged the RIBA to give me some data about what other countries were doing, because in this country we're notoriously bad at not looking over our shoulders. And to their amazement, they found that Germany was in fact offering huge incentives to people. Phoebe MacDonald, who was the project worker at the RIBA, said that Germany was offering a 30,000 euro grant to anybody who wanted to retrofit their house and a low interest loan of 0.75%, which of course any government could borrow. The take-up figures have been significant in Germany. Okay, next slide. This is, by the way, this is not a picture of Germany. So here we have the statistics in 2016, 276,000 renovations, dwarfing the 14,000 achieved by the Green Deal in this country. I remember when the Green Deal was launched, I was at the RIBA and I asked a question of the principal organizer. I said, have you done a risk assessment of your Green Deal? She said, we have, and it's absolutely terrible. So they knew it wouldn't work. Next slide. This is the front cover of the Letty Climate Emergency Retrofit Guides, just so that you know what you're looking for when you go online. And it runs to many, many, many pages. I think there are about 205. So don't give up. It's all there. It just takes a little bit of digesting. Okay, next. And oh, sorry, this one's a little bit faint, but this is quite a key page in the document because it basically identifies the most sensible targets that we should be aiming for if we're going to achieve what they call Letty best practice, which is essentially very similar to Passive House and what's the other organization? The Green, whatever it is. I'll come to it in a minute. And basically, if you look there, you'll see they've got two columns. One is constrained, which is buildings that are historic or in conservation areas or have other constraints that make it difficult to retrofit them, and unconstrained. And strangely enough, my house was never listed, even though it's 17th century, and so I fall into the unconstrained category. I am, however, in a conservation area, so it meant that I needed planning permission to do what I did. But these figures here give you the sorts of U values that an unconstrained house should be aiming for. Next slide. And oh, here we are, AECB, that's the standard. So Letty Retrofit is aiming for 58 kilowatts per square meter per year. AECB new build is 53. So you can see it's very close to what it needs to be. And they say building regs 2021 is as low as 60. I think no builder ever achieves that. Okay, next slide. Now, the first thing that we did was we actually borrowed a thermal imaging camera from our energy supplier. And I'd forgotten that I'd asked for one. It suddenly turned up at just the right time. March 2020, I think. if the years haven't flown past too quickly. And this, what's really interesting about the thermal imaging camera using it in March is that because the internal and external temperatures are substantially different, you can see my timber frame building shows all of the problems that you get with oak, not softwood, but oak, because the entire oak frame is grinning through with different colors. And the reason oak is so bad as a thermal performer is that it's such a dense material. It's got very small air pockets. Softwood is much, much better. And in fact, it's probably just as well that we haven't got masses of oak. So you can see we've got a small upper floor here with the studs showing, and then a larger ground floor. And
can you clarify, please, what do the colours mean? Is the purple very hot or very cold? Or?
The purple is performing well as an insulator, and the yellow is performing badly. So you'll see doors, eaves, and above. Can you see my cursor?
No.
No. Okay. Above the door on the left is a yellow spot, and that's the end of a beam, an oak beam. So all of the problems are showing through. If we go on to another slide, there you can see the front elevation of the building, and again the windows are showing yellow. They are, in the original building, they were actually double glazed, but only with a 6mm cavity. So they're not performing terribly well. And the timber frame is clearly visible. And if you go on to the next slide, I think, yes, that shows that the plinth is obviously a very, very weak point in the building. And that's because it was made of, in fact, we had to basically rebuild the plinth when we did the original renovation. So it's just a thin concrete block, and the heat is just passing straight out through the plinth. So there we have absolute textbook performance problems, which show us exactly what we need to do, which is to insulate on the outside of the building. And many people will say, oh my God, that's far too radical. But it's the only way to do it properly. And I think that we just have to get used to the idea that brick facades are a thing of the past. Okay, next slide. So this is what my house looked like before I started work. And you can see I've marked up on here for the planners to show them how adding insulation to the outside of the building increases the height of the roof, the height of the chimney, and also the width of the building. So there are marks to show that it's going to get bigger generally. The planners had absolutely no problem with this. And it was only a neighbor who objected to the proposal to use zinc on the roof in the kitchen because she thought it would make her life very noisy. But the wonderful thing is that now that I've insulated it, I can't hear her coming down her wooden stairs in her Dr. Scholl's. So moving on to the next slide. Okay, now this is a quick sketch to show you early ideas about how we would insulate on the outside. And you'll see on the right-hand side is the ground floor construction, which is ash floorboards, hemp, which is our favorite material, and then Foamglas, which is also a favorite material of ours, creating an insulated ground floor. You can see the sort of concrete plinth, then Foamglas being applied to the outside of the plinth, and above that you can see the existing timber frame wall with a new timber frame added to the outside, and then wood fibre board. So we've added 150 millimeters of insulation on the outside, and we've improved the existing insulation, which in a moment you'll see why we had to do that. So move on. Okay, so this is just an image of the window team getting stuck in to take the windows out. the windows came from Lithuania, of course, and this team is kind of Ukrainian, Polish, Hungarian, and of course, when you ask them a question that they don't want to answer, they don't speak English. It's great fun. The removal of the windows was done carefully so that we would minimize waste. And in fact, I took all the frames off because the windows were untreated timber, and I've set those aside to use them as firewood. And the only thing that we put in the skip was the actual opening lights, which saved space and reduced landfill. And you can see the construction of the external wall here. It's render on insulation on stud work. Okay, next slide. Oh, and here's the pile of my windows ready to go in the skip. Next slide. This was the reason why we had to do some serious work to the insulation. This is in fact rock wool. And what you're seeing there is a hazelnut shell. And in addition to the hazelnut shell, there are masses of enormous voids, which the mice have just created because they love destroying things. They have chewed their way through every bit of insulation in the house to the point where some of it we had was good enough to keep, but most of it had to be taken out and disposed of. I contacted Rockwool to find out how we could get them to take their material back. And they said, oh yes, we do take it back, but you'll have to pay us £80 a ton and deliver it. So it's not much of an incentive to recycle. Next slide. All right, so we've got to, oh, that's pretty good timing. First 15 minutes and a chance for questions.
Well, as there's only a few other people listening, I suggest that you all unmute and ask your questions, because you haven't written anything in the chat, so I don't know if that means you haven't got any questions.
I've got a question. So that insulation was in, where was it in the construction? Sorry, we used to live in a old thatch house and it was absolutely wattle and daub. There wasn't any kind of insulation of the wall going on.
Oh, don't say that, because wattle and daub is quite a good insulator.
Well, yeah, but not any modern insulation. So that insulation that the mice had chewed through, where was that? In
that
the lot?
Was, well, I'll explain that the building originally was clad with brickwork by the Victorians. And in doing that, they built the bricks around the oak studs. So it was a full brick at ground floor level and a half brick at first floor level. The half brick saved our lives, but the full brick was a disaster because it was always damp and the whole oak frame rotted. So we replaced it with a new softwood frame at ground floor level, which is kind of how conservation encourages you to go. And then and those were 120 mil studs with 120 mil rock wool between them. So that was the insulation. And at the time in 1985, that was considered ludicrously good. Everybody was saying to us, why on earth are you putting so much insulation in? You only need 50 mil.
So then there wasn't anything left of the original building at all on the ground floor, because you'd taken out the timbers and you'd replaced whatever it was between them.
Not entirely, because the main posts did survive.
Okay.
They were meaty enough that they were still there, and so that meant that we could keep the whole thing standing while we did the work.
So how good is the wattle and daub? You said it was quite insulating. How does that compare with rock wool?
Well, then you start getting into really complex questions of thermal performance and thermal inertia and all of that kind of thing. And actually, the whole debate around U values rages on, and rock wool gives you a U value of well, a thermal conductivity of 0.38. Wattle and daub is nearer to about 0.2 7, but because it's breathable and therefore remains dry, it performs significantly better than rock wool, which is always full of water. If that makes sense.
I think our wattle and daub was a really thin layer though, because the thermal camera, you could just see the radiator up through the wall.
Yeah, it tended to be sort of 60 to 80 millimeters thick, which in some buildings is pretty good. But did you take it out as a result of that?
No, it's partly why I moved to a different house actually, because it is quite hard. You know, it was a thatched house, it was a listed building, all of that stuff, and it was increasingly, you know, becoming obvious that energy efficiency wise, we'd have to work so hard to improve. Although now I live in an Edwardian house, and there's other problems, you know, and there's other challenges. So, so much for a love of old houses.
Thank you. Do Helen and Maria have any questions?
I do have a question actually for Ralph, which is, did you do any moisture monitoring in the house? Because I'm aware it tends to be an issue with some retrofits. And I'm just thinking timber frame potentially, I don't know. You might have chosen to be on the cautious side of things. I don't know. Did you do that?
I was living in the house, so I had a pretty good idea how it was performing in terms of moisture migration through the fabric. And one of the issues that we were aware of, and was in fact manifesting itself in our house, was that the rock wool insulation, particularly in the roof, was retaining moisture and causing the plasterboard to smell damp, especially in the summer, where you get an inversion of the flow of moisture from outside to inside rather than inside to outside. And what's really interesting about having put the sheep's wool insulation on the outside, which I haven't identified what it is yet, but that's the first layer that we added, sheep's wool insulation, 70 mil thick, and then wood fibre board beyond that. Those two materials are highly vapor permeable, and we have no issues now with damp smells internally. So the whole question of mold buildup in the fabric just falls away the moment you start using natural materials.
Yeah. Great, thank you.
We're on an early start looking at retrofitting our cottage. We have an early Victorian Gothic cottage that is listed and in the conservation area. It was done up about 10 years ago and does have the loft insulated, but obviously the walls are just brick and quite thin. Where would you recommend that we start the process of looking to retrofit, and who should we approach first? Any advice?
Have you got any kind of architectural experience yourself?
Not necessarily architectural, no. I have got experience in the building industry from a long time ago, but it's limited.
Okay. I mean, you can either engage somebody who knows about retrofit, which is always recommended, or you can use your common sense, because in a way your problems are pretty simple. The main issues that you face are, how do you deal with ground and first floor junctions and then the eaves? Because those are the weak points, and that's where you'll lose all of your good work if you just apply insulation to the brickwork around those zones.
Right.
The type of insulation you use will probably depend on whether your building's ever been repointed with cement mortar or whether it still has its original lime mortar.
No, it does still have the original lime mortar. There were some concrete parts done, but it has been replaced with lime.
Well, that's brilliant. because your building will actually perform significantly better than if it had cement mortar. So you're already one step on the road. And I would say that you want to look at some way of, well, just one more question. What are the ground floors built of?
It's all brick. The whole thing is brick.
But the ground floor is solid or suspended?
No, it's solid. It's literally on earth. We know that because when we had the fireplace sorted out last year, that's all they found. It was just earth. There was no foundations. There was nothing. No plinth. Just bare earth.
Right. And the ground floor is just brick laid on bare earth?
Yeah.
Okay. I mean, that's pretty easy to lift. So you could insulate it. You will have heard me refer to a material called Foamglas,
Yeah.
which is a phenomenally good, solid and load-bearing insulation material with a very low embodied carbon. It's made by DuPont, I think, one of those American corporates. And oh, here we are, Foamglas, right. And you can lay Foamglas straight onto the ground, and then you can lay your bricks straight onto it. So again, minimal energy penalties, minimal waste, and it will massively improve the performance of the building.
Oh, interesting. Okay.
Foamglas did a lot of work with us in the early days on listed buildings, and agreed that we could use it on ground floors instead of using concrete slabs.
Do you find conservation officers particularly amenable to anything like this? Because I know ours would rather us dig a sort of cesspit and have cholera than anything else.
Where do you live?
Cambridgeshire.
What, South Cambs?
No, well, actually Huntingdonshire technically.
Okay. Yeah, I mean, you've got dinosaurs everywhere. I think if you were to get Foamglas to talk to the conservation officer, you might very well find that they're open to it.
Okay, we can try. Thank you.
Yep. And then the walls you obviously want to insulate with. Don't go anywhere near things like Celotex. It's absolutely dreadful for historic buildings.
Okay.
But you could even look at using a hemp and lime internal lining. You may not know, but we were the architects who brought hemp and lime to this country in 1994 and did the original research. We did a building in Bury St Edmunds where we lined the walls with just 50 mil of hemp and lime, and the difference is extraordinary.
Okay, thank you. That's really helpful. Thank you.
Okay. Shall we go on to the next part where you see what we've done? Okay, so the first slide is a picture of the Foamglas added onto the plinth. The blocks are, in our case, 120 mil thick. They're glued onto the plinth, and then they are rendered with a lime render. The guy who did the lime rendering said, "Oh my goodness, I don't need to put any mesh on this. It's holding absolutely brilliantly. And in a single coat." And then I looked at the technical specification for Foamglas, and they use it in Switzerland for cladding buildings, multi-story buildings, and they render straight onto it.
Sorry, Ralph, is it the black bit that we're talking about?
Yeah, it's the black bit at the bottom. Foamglas is a black glass, recycled glass material, which is full of air pockets, and has a very, very good thermal performance. So it deals with that horrible yellow strip of cold at the base of the building.
It was yellow on the infrared, yeah.
Yeah. Okay, move on. Right, and this is actually a picture of the floor that I'm sitting on. We renovated this floor in about 2010, and we took up the old suspended timber floor, took up the old clay bricks that were holding up the sleeper walls, and put just a layer of sand on the earth, then a 100 ml Foamglas layer over that, and then this wooden frame on top of the Foamglas filled with loose hemp. And it's really solid, really warm, and absolutely the right answer for any older building where moisture is an issue, because Foamglas doesn't allow moisture through. It's like a damp-proof membrane, but it doesn't cause problems with pushing water up walls, for example. I don't know why, but it seems to work. Okay, next. So that's the floors. I put this one in because it just illustrates Pavatex's little bit of advertising for their retrofit insulation. Was probably not retrofit, this is probably a new building, but essentially what you need to do with Pavatex to make your building energy efficient. And what it shows is that the whole building is wrapped up with Pavatex, this wood fibre board, originally from Switzerland, but now made in France. And you'll see that all the junctions look immaculate. Well, of course, you can never achieve that in reality, but we got pretty close to it. And you tape the joints up. So the whole building is wrapped up. In our case, you will have seen that we stripped off the roof tiles, we stripped off the render, and then put insulation on the outside in the form of sheep's wool between studs, and then another layer of tongue and grooved Pavatex wood fibre board on the outside of that, 80 mil thick. So when we move on, you'll see some of the images of what it looks like. Right, here's the Pavatex arriving from Europe on pallets. That's fine, Nicole. That's okay. Or Nicola. Now here is a picture of us stripping the building back, and you can see one wall is actually built of hemp and lime cast in between the stud work. So that was not affected by mice, and we were able to leave it in place.
So that was the left wall, was it?
Sorry?
That was the left wall that looks grey.
Yeah.
Yeah.
And the front wall, which has got the sun on it, is the wall with the rock wool in. And that's what the mice had a field day in. And you can see there the windows have already been put into a softwood frame, which is the same dimension as the studs that were then applied to the outside of the building. So move on. Okay, here you can see the mice destruction at first floor level, where they've just completely shredded everything. I don't know where it's gone. I don't know whether they eat it or whether they just chew it and spit it out and compact it, or what happens, but it's extraordinary how the original rock wool just becomes a whole, it's almost like a facade of rock wool with nothing behind. It's really frightening. And I bet there are millions of buildings like this in the country. People say, oh yeah, we've got rock wool insulation, it's great. Okay, move on. Right, so here's the render coming off. And in fact, the bit that you can see on the left is the 1984 extension. And because that was all new softwood stud work, the mice weren't able to get into that. And so we were able to keep that insulation and then just add more on the outside. So you can see the softwood stud work there with the windows applied to the outside. And at this point, because we're working from the ground up, the roof is still on, and we're slowly working our way around to take off the cement render on expanded metal, which you could just pull off because it goes rusty so quickly. And I just had to get the builders to be careful so that we could separate the metal out from the cement render. We kept the cement render as hardcore, but put the metal in the skip. And if you do that sort of thing, you can save huge amounts of money on skips. Just means a little more time and care. Okay, next. Right, so this is a picture of the inside. I just put this in because it shows the need for air sealing both outside and inside to ensure that you don't get drafts coming through. We actually put sheep's wool between the window frames and the stud work, and we learned about this when I went on a building center tour of Austria about 20 years ago, and the Austrians at that time were already retrofitting, and they were using sheep's wool as the expanding foam between the windows and the stud work, rolled up and pushed in and then taped inside and outside. And the wonderful thing about sheep's wool is, first of all, the mice don't like it because the fibers are more like steel. Rock wool fibers are much softer and they can chew through them. But natural materials are significantly more durable. And the sheep's wool that you buy now is treated against moths, so that's not a problem. And it provides a really good air barrier in addition to the tapes that we put on. So there you see the process from the inside. Next slide. Okay, here we have early stages of the timber frame that was applied to the outside, 75mm stud work with sheep's wool between, and where the rock wool was bad, we took it out and replaced it with sheep's wool as well. And you can see on the left then the eventual wall build up. So you've got the stud work added to the wall so that it's level with the windows, and then 80mm of tongue and grooved wood fibre board added, fixed to the face of the stud work up to the windows. So there's your 150mm of additional insulation. And at that point, the plinths haven't been insulated and the roof hasn't been done. And we cut the sheep's wool like that because if you were to cut it to fit between irregularly spaced studs, you would waste so much. And we don't believe in wasting things. So a little bit more work again, careful cutting with a very sharp knife, and you can get the wool in there so that it stays in place and does an amazing job of insulating the wall. Next slide. This is the front wall, and by this point, our builder had sort of given up on us because it was all too much like hard work. So I ended up doing this myself. You can see the two angles of the wall. This is typical of timber framed 1.5-story buildings where the thrust of the roof pushes the eaves out. The first floor remains where it should, and then the plinth gets pushed out because it goes rotten and moves. So I had to work to those two angles by breaking the studs on the central girth, and that was a hell of a job. Especially, you can imagine putting a rigid board material like wood fibre board over that surface and trying to get it to change angle. I did manage to do it by having a straight cut, but those are the challenges of old buildings. Next. Okay, so here's just another one of the builders when they were still on site, putting the wood fibre board on. The fixings for the wood fibre board are quite interesting. They are a plastic. Well, it's like a washer, but it's got a flange, and you put a very long screw through it and screw it in tight so that it pulls into the wood fibre board to hold it in place. It's a really nifty bit of design. And you can see there all the fixings are in line with the studs. Next. There you can see it again, starting to put window sills in. Those are preformed sills that are fixed to the underside of the windows, and then you bring your render down onto that sill. That profile is actually really clever because it has an upstand at the edge, which means that the water, when it rains, doesn't run off the edge of the sill and stain the wall. It runs just off the front. And it's a fairly standard European detail. They've got most things sussed over there. Next. So here's the Pavatex pretty much in place. And you can see we're starting to strip the roof now. Next. Okay, this is why we had to strip the roof. These tiles were put on in 1984. They were made by Goxil of Barton-on-Humber, and they had a 30-year guarantee. Well, in year 34, we decided to do this work and discovered that the frost had destroyed pretty much all the tiles on the north side of the roof. So what we decided to do was to strip all the tiles off and reuse all the good ones on the original 17th century part of the house and change the roof finish on the 1984 extension to zinc, which is what caused the ructions with my neighbor. But it was a great move because it meant that we could keep as much of what we had as possible without throwing anything away. We could bring in a new sustainable material in the form of zinc and link the two together with a zinc valley. So that was what we were faced with there. Next slide. Okay, that's the tiles coming off. At that point, we hadn't got all the scaffold. Oh no, we must have had the scaffolding up, yes, because I wouldn't have been able to get up there. But I took all the tiles off myself because they come off really easily, stacked them on the scaffolding, and then my brother and I did the roof insulation, repairs, and overcladding with Pavatex. That's the original chimney in the middle, and it's pretty short. It was built with cement mortar and flaunched at the top with cement mortar, and of course it's suffered massive frost damage and the brickwork actually split right down the middle, so we had to rebuild the chimney. Okay, next. This is just a quick sketch to show the wall build-up. You've got the main stud work on the right-hand side. Then you've got in this is the kitchen extension, and we had actually added a new stud work wall on the outside prior to starting this because we put in a sliding door which became a pocket door. But you can see how the principle is that wherever possible you link the wall and roof insulation so that there are no cold spots. Okay, next. Right, and this is it going on. So you can see the walls are darker because they've already been weathered a bit, and we're putting the roof on and covering it with polythene. This was done last August. You form the valleys by just cutting carefully and butting the Pavatex one on top of the other to get the completely airtight seal, and the verges up the gable are also butt jointed and then taped. So it looks pretty much like the Pavatex advert, and you feel like you're really making a difference when you get everything nice and tight. So next. this is my neighbor helping me. He's 83. And he said, sure, I'll come and give you a hand. So this is the build-up of the roof with the zinc. The Pavatex is underneath the membrane. Membrane goes on top of that, then a 50mm batten and plywood on the batten. And because it's all pretty level, it was quite easy to do without having fancy ladders and that kind of thing. You just have to fix the plywood as you go. And then on the left, you can see Pavatex supply a red membrane that goes over their material to protect it if any of the roof tiles ever blow off and you find that your roof is exposed to the elements. Okay, next. Right, so here we are starting to work on the chimney, and you can see at the top how that chimney is in fact lined with an isokern flue liner, but because it wasn't protected at the top, it's just frost damaged to the point where it doesn't exist anymore. So that was basically why we had to take the whole lot off. Next. Okay, here's the new chimney. And we decided lime mortar. The bricklayer was delighted. He said, I've not really worked with lime mortar before, but it's amazing stuff. So don't be put off by bricklayers who say, oh, I've never used lime mortar. It's easy as long as they mix it properly. The key is to mix it for 20 minutes, not 5. So it becomes nice and fat. And then you can flaunch the chimney with lime mortar. And in fact, we put a hydraulic lime wash over the flaunching to protect it from the frost, and it worked pretty well.
So what is flaunching?
Flaunching is can you see the top of the chimney? That's just rendered over with a lime mortar.
Okay.
But it's got a slope on it to let the water run off. Okay, next. Right, so here we can see the zinc is actually already on the kitchen wing. It's standing seam zinc, which is laid on around the roof lights. Interestingly enough, in the massive downpour we had at the beginning, second week of August, the middle roof light leaked. And I know why it's leaked. It's because the water came down the roof so fast that it got under the flashing at the top of the roof light, because the zinc moves quite a lot in the sun, and the flashing had actually come loose. So I'm just going to have to go up there. I'll open that roof light up, put the ladder up, go up from inside, and I'll stick the flashing back on with the mastic that they provide. The roofer did actually warn me that could happen, but we didn't want the roof lights standing so high above the roof that we would be completely bomb-proof. On the right-hand side of the picture, you can see that's the Pavatex roof with the battens all in place and the gable ladder. Do you know what a gable ladder is? It's the structure that goes up the gable, which projects over the face of the wall, so that you've got a weathering protection.
The thing we're seeing on the right, yeah.
Yeah. Okay, next. Right, and then this comes on to the dormers, which were a serious challenge because in order to insulate them, they obviously had to become larger, and the original design therefore didn't work. So I spoke to the roofer who did the roof tiling, and he said, "Oh, do them in lead for you." And that meant that we could use 40. We had to use 40 mil of Pavatex instead of 80 to prevent the dormers from getting too big. And then he put slates on the roof rather than pantiles, because the pantiles had never worked on that little patch of roof. They were the module was too big and it always looked wrong. But I think he did a pretty good job of it. I had to physically show him how to detail the lead work around the wooden windows. But once he saw what I was talking about and could see how I was doing it, then he was happy to do it. That's often the way with builders, that you've got to cajole them by showing them what's possible, because they usually only do what they did yesterday. They can't conceptualize things terribly well, and they certainly don't know how to read drawings for the most part. But it worked pretty well. And you can see under the dormers is a zinc gutter, which has no joints. It's a pretty nifty system. You basically push one section into another, roll it over and put a mastic in, so you haven't got any of the normal metal joints that you have on things like Lindab guttering, which then end up leaking. So you have to put the whole gutter in one piece, but with 4 people, that was easy enough to do. Okay, next. And then this is a picture of the other side of the house with the zinc. We went for red colored zinc because we just felt that a natural color might be too jarring visually, and it actually works really well. The roof light in the middle there, you can see, we had to take out and completely rebuild because it needed to be 100 mil above the zinc, and the zinc was, because of the extra insulation, was significantly higher above the roof than the original finish. So we had to rebuild that roof glazing by taking the glass panels out and building a much bigger section. And if any of you come on the tour, you'll see how it works. And then on the left, you can see we're still working on the gable end, and things are work in progress. Okay, next. Right, so here's the render going on. And that again is a proprietary system. It's a high lime content render put straight onto the Pavatex, and then you can see the guy on the right is bedding a nylon mesh into the render to provide what you would get with a fibrous mesh. But this is basically all out of a plastic drum, plastered on 6 millimeters thick, and the mesh goes into the base coat. They then prime it and they put the top coat on, which is only a couple of millimeters thick, the next day. And that's your wall done, and it's all pre-finished in color. Next. So here I took this one yesterday just to show you the finished look, because we changed the color scheme. We've gone for a sort of gray, and we painted the boarding the same color. You can get color matched wood stain quite easily. We put back our weather vane there on the top so that we can see which way the wind's blowing. It's really useful when you've got a storm to know which way the wind is blowing. And that's really what it looks like now. The plinths haven't been finished, but other than that, the building is pretty well insulated. We actually had it insulated last winter and found that the temperature inside remained above 18 degrees overnight, rather than dropping down to 11 or 12. So it has made a massive difference. And in fact, we just lit the wood burning stove in the last couple of days because it's been pretty chilly. And yesterday we burnt 4 logs. Today we've only burnt a couple of logs. It's ridiculous. So it is working. Okay, any questions?
Well, once again, I suggest you just unmute and ask, because there's not very many of you.
Can I ask you about the ventilation in the building?
Well, we haven't dealt with that yet because I'm doing everything step by step. I've made provision to put in a mechanical ventilation system, but up to now, we haven't done that because the windows actually have a little setting that allows you to lock them slightly open. So in the room where we have the wood burning stove, I tend to put one of the windows just slightly open. And in the rest of the house, because we've got such large volumes, the ventilation isn't really an issue. We can vent the roof lights because they're Velux roof lights and you can just click them open. And at the moment, it seems to be fine. I think that the real proof will be this winter when everything is finally sealed up, because the plinths aren't sealed up yet. And we may find that we've got to put in a ventilation system. But again, I can do that myself. I've got it all worked out. I've worked out the pipe runs through the roof space. So I can deal with that. But it's another £5,000, and I think we might decide that we can vent the windows and open and close them rather than having an all singing, all dancing system.
Would that be MVHR?
Yes.
Yeah. You haven't thought of a demand control system?
No. This is an old house.
Well, if no one else has got any more questions, I've got a couple. You said you did it bottom up. Was there a reason for this? Because
Yes.
I would have thought it's often you need to do the roof first, otherwise you're not got enough eaves.
Yeah,
a lot of eaves.
that you'd think that was the case, but the reason we did it bottom up was that the sequence of work meant that we in theory would have been able to do the rendering. It didn't work out that way, but we would have been able to do the rendering from the ground, because the maximum height of the ridge of the eaves is 2.7 meters above the ground. So my thinking was, we'll do the roof last, and we'll only put the scaffolding up once we've rendered it. But what actually happened was that the guy who was going to do the rendering didn't come, and eventually went out of business. And so we decided to do the roof before we rendered the walls. And then we took the scaffolding down in order to render the walls. But yeah, often you have to think slightly back to front with these buildings to make it as cost effective and time efficient as possible.
And I have one more. This is probably a stupid question, but what makes you say that zinc is sustainable? I mean, what's different about it?
Zinc is fully recyclable, and it melts at a pretty low temperature. So if it were ever to be taken off, it could just be melted down and, a bit like lead, made into a new zinc sheet.
I was going to say that would apply to lead as well, but lead is a bit valuable.
Lead is valuable, and also it's a more toxic material, as we know from Notre Dame, because the whole roof was lead there and it vaporized in the fire.
Okay. Because I've noticed it being used an awful lot now, and it's not that pretty. So I think the standing seam is fine, and actually it looks rather like lead with rolls. It's very thin and very light, which means it moves quite a bit, but no, it's quite a sustainable material. okay.
And actually, one of the interesting things that I discovered, it's funny how these things come round, but when we did the original work on the other part of the house, which I haven't talked about because that was done in late 90s using hemp and lime, and it didn't require additional insulation. It was all ready to go. But that part of the building, we fixed Lindab guttering, which is galvanized steel. And when I gathered the rainwater and watered the plants, I noticed that they weren't growing as well as they would with water that had come off a plastic gutter. So I contacted somebody, I can't remember who it was, and just asked, is it possible that we're getting small amounts of zinc in the rainwater, and could that be affecting plant growth? And they said, oh yes. Now, the zinc that we've put on now, the gutters are actually coated with something to stop them from oxidizing, so you don't get that zinc oxide in the rainwater.
But it's still the roof. The rainwater's landing on the roof, which is zinc, and going into the gutter. So I don't.
But rainwater is somewhat acid.
Yeah.
And it's dissolving the zinc and causing it to oxidize, and that's then deposited in the water. So what I'm going to do with my Lindab gutters, I'm going to paint the inside of them, because they are actually starting to rust. The zinc coating is not as durable as they say. And unless you have a massive fall on them, the water can sit in the gutter and it can cause rust. And so I'm going to get a bituminous based paint, or maybe a galvanized kind of protecting paint, which isn't zinc based, and just paint the inside of the gutters. And that will not only stop them from rusting, but also stop this problem of zinc in the rainwater.
Right, so it's only if it stays wet that you have this problem. Yeah, I see what you mean. Yeah. Okay.
Well, I mean, how pretty it looks, I suppose we'd have to go on the in-person tour and have a look for ourselves, really.
Well, it looks okay. It's just different, and I've noticed it being used in a lot of other places in Cambridge, and some of them look nice and some of them don't. But yeah,
that's fine. You're entitled to your opinion.
Well, thank you very much, Ralph, for taking us on that whirlwind tour.